So thanks for joining us for this rather spontaneous and, as we see it, informal session. The title is here, History of the Classification, How Big Is It? And as you will see, that's a bit ambiguous, the question we ask. Is the classification big, or is our project big or too big? And that will be one of the things we want to look at. And to start with, I want to tell you how we ended up doing this project and how we got together, because people have been asking this question and apparently we have not sufficiently addressed it in the other presentations. So for me, as I'm the senior in this project, it began in the late 80s or early 90s in a way when I was a student in Freiburg University studying with Otto Kegel, who, in fact, as I was happy to learn over the course of the project, he was at the Chicago group theory year in 1960, 1961, because Frankfurt University had a cooperation agreement with Chicago University starting in 1940, because computers were relatively, well, recent in the game, even in the late 80s or early 90s, compared to what computers do now or have been doing since the early 2000s. There was still this debate going on, or it was visible, of what do computer-generated proofs do to the idea of a proof. Well, we've moved far from that. In the meanwhile, I think if you think about things like experimental mathematics, etc., there's a lot been going on, and no one probably would really argue now that, well, computers should not be a part of serious mathematics. But that was quite prominent back then. And so somehow I was interested in the thing, and the problem I worked on in my diploma thesis was a typical classification problem. Well, we know this because the classification proves it, but please give a proof without the classification. I mean, that was a standard thing you would put out in the 80s and 90s, I suppose, or even now. Prove it without the classification theorem. And luckily it was possible, so I got my diploma, and then I moved on to do a PhD in history. And when I had my first permanent position, that was in 2010, when I went to Aarhus for a professorship. I always like to quote that because it had this wonderful title. It was a professorship for the history and philosophy of mathematics and computer science. And you could easily cross out two of these words, and more fitting for me, but well, it was an ambitious thing. And in Aarhus there was Henrik Sørensen, who is now in Copenhagen, who had a keen interest in experimental mathematics and philosophical questions concerned with what a mathematical proof is. So I thought, well, this would be a nice environment to try to do something about the history of the classification of finite simple groups. And I sketched out a program back then when I presented my research interests to the department. Well, then in 2011 I went to Wuppertal, and it was thwarted by this change of geometry, number theory, Arbeitsgemeinschaften. We would still have to do that. We agreed on that, that we would do that later on. And group theory. And well, it was easy to find some people for some things, but it was quite difficult to find someone for statistics. We didn't find anyone for complex analysis. And for group theory, I asked around, and Reinhard Sigmund Schulze said, well, there is this person in Halle, and she's at algebra, and she might be interested in history of mathematics. And it was easy to find out who that person could be, because that's Rebecca, and Rebecca has the professorship for algebra. Is that right? Yeah, it's called Professorship for Algebra in Halle, and we communicated about the possibility of Rebecca writing this piece on the history of the group theory meetings, the BEAR meetings at Oberwolfach. And I think that's where you can correct me later on, but it came already out in that process that part of the classification stuff was very prominent in Oberwolfach, not until 1960, but in the 60s then. Thomson presented large chunks of his work there. Fischer presented there, Janko was there, so a lot of the players in the finite simple group thing were in Oberwolfach. And that must have been the point when we discussed the classification of finite simple groups, and it turned out that Rebecca had an interest in the history of this thing too, or was willing to develop an interest, as you can comment on that later. And so that is probably when we both thought, well, if you do it, you have to do it in this combined expertise from history of mathematics and a person who really knows the mathematics involved. Well, and then we wrote an application and received funding and started going really only seriously last year, I think, in terms of spending the money. We went to the archives, we were in Chicago and in Princeton and in Austin, where I told that story earlier, where we learned that at least a substantial part of the Brouwer papers is in the Veit papers and not in the Brouwer papers in Harvard. And we found lots of interesting stuff that has not made our project more surveyable, really. So there are loose ends popping up everywhere. And we want to discuss some of these loose ends shortly. So why was this thing interesting to me? One point, of course, is it was interesting to me because it is an interesting, well, I shouldn't say piece of mathematics, but it's an interesting part of mathematics in a way, the whole community and the result they produced as a group. But it dawned on me quite early on that this was special in various regards. It is, of course, something that happens through the Cold War. And there's been a lot of work being done in the last 20 years in history of science on Cold War science, well, the last 30 years. And we learned a lot about Cold War science, but that means Cold War science. We don't know that much about Cold War mathematics or the impact the Cold War really had on mathematics. We have some things, of course, but the large picture is, if you ask me, a bit too blank still. So yeah, this seemed to me to be a good starting point to try to study the impact of Cold War politics on mathematics by taking such a large group as the classification community, and also see how or if the Cold War has an impact on pure mathematics in that way. And we found early on that, well, through the massive amount of funding that was there and that also went to pure mathematics, especially to algebra, partly in context with cryptanalysis and these things, because people knew that's a branch where they would need expertise in algebra and group theory. So there was a huge impact in terms of, there was a lot of funding for PhD students, etc. And this then led, at some point when we discussed this, to the idea of, well, when we discussed our proposal to the German Research Foundation, it's not really appealing to have a project called History of the Classification of Finite Simple Groups, because you have to sell it to the history of science community, and history of a theorem or so is not a selling point. And that's when we thought about big mathematics, because they all can connect to this big science aspect, and well, it seems that it went through. And we have discussed what big mathematics might have been or might be at various points over the last few days, and there's still some blanks to fill here, but that is one of the key points that was of interest for me in this whole thing, to really link the history of mathematics in the Cold War with the history of science in the Cold War, because that's very often two fields that are two worlds that seem to be too far apart, I think. And that connects to the question of, well, how did the structure of mathematical work change? Something we have discussed here over the last 3 weeks in various contexts. Norbert mentioned it on Friday in the history of the IMU presentation. A lot was going on after World War II in terms of the facilities for working in mathematics. So new structures such as new institutes, conferences becoming increasingly attractive, specialized conferences becoming an increasingly attractive tool of doing work in mathematics, such as the conferences we know in Oberwolfach, but also, which is reflected in our project, specialized conferences in the history of finite groups, or even in the history of finite, or not history, theory of finite groups or theory of finite simple groups. And then there's that aspect that I mentioned earlier, it is like a magnifying glass for many things, but also for the changing ways of how we perceive of the nature of a proof in mathematics. So we have these two aspects that we mentioned earlier, the computer aspect, but also this thing that is really, can really make one nervous. This proof is not surveyable. It's too large, and you cannot just go home and read and hope to understand it in a finite amount of time. And not all original parts have been written in a very accessible way. We have the interviews that Joe Gallion did with some of the players in the 80s, in the early 80s, reflect that quite nicely when they discuss whether Michael Aschbacher might be a candidate for the Fields Medal. And the consensus coming out of these interviews, when we put that together, or I put it together, is, well, from the substance of his work, yes, but he just doesn't write it up quite nicely, so it's unreadable for outsiders. So this is a real big problem, that too many parts of the classification thing might have seemed inaccessible to outsiders. It's a very specific set of techniques in the classification thing. So what can we think of this as a proof? Well, players themselves were nervous. That's why we have the second generation proof to be, well, finished soon, maybe. And if I'm not completely wrong, there's people talking about a third generation proof. And see, you have seen, or many of you have seen the photo Rebecca showed with how many books the second generation proof already entails. It's a massive thing. And yeah, so what is a proof? And what's the importance of trust in that process, that a community accepts something, socially accepts, as Huey Manning once put it, socially accepts something to be a proof in mathematics. So we have tons of questions no end really, and we want to tackle a lot of these questions, but we are not quite sure about how we could do that best in terms of products, in terms of what might be a good way really to, well, to communicate about this. I wanted to say write about this, but perhaps writing is not always the best thing to do in disseminating what we will find out and have found out about this whole process. And that's, I think, the point where we want to enroll you and have the suggestion that you perhaps might help us a bit just now, because we want to map out on the blackboards of what we want to do and perhaps discuss with you where you see blanks in what we are thinking about right now. And that's where Rebecca is well prepared.
Yes, we'll see about that. But I will definitely join you so that we can use the blackboards and also your suggestions. Thank you for introducing. I did a piece of homework before we start with this, because one of the questions I got most recently was about a quote that I showed in several presentations by John Alperin from a letter that he wrote to Walter Veit. There was this thing like, the ball game is over, I'm convinced that the techniques lead to a proof, blah, blah, blah. And then there was the end of the quote, the end of an era, end. And then I was asked by lots of people, how does this continue? What's the remainder? So I looked it up, I found the letter, and I just want to read briefly how this goes on, because so many people ask me. The end of an era and the opening of a new one. Very exciting. Probably we should have a big conference to celebrate this. And then John goes on with some ideas what type of conference this could be. And as we know, there was a bunch of conference happening later. Okay, so taking up what Volker said, this will probably go wrong. I'm going to be very vulnerable here and basically show what my brain does with this project. First of all, oh no, shock. First of all, Volker already mentioned that we find it challenging to see how we can best share our knowledge. And I don't mean products like big books in 10 years' time, I also mean on the way. And I have lots of thoughts and questions about that. Questions? Yes, very good point. My brain works with questions. And I think that one way to structure the work that we do is around all the questions that we have. And I will be curious to learn your questions. So I can put them on the board because maybe you have some that we don't have, and maybe you can help us see some blind spots in this whole project. And so I need a third big blackboard, because another one that goes in this category is the question of entry points. And this is connected to sharing the knowledge, because depending on what entry point you take, you will access this project in very different ways. So let's say that your entry point is people, because you find the people interesting, like Danny Gorenstein. He's a fascinating person in this whole project. So what happens if you start with people? I will share some thoughts on this in a moment. What happens if you start, so for me this would be very natural, to start with the actual maths, the theorems, the results. Totally different entry point. How about starting with the timeline? And that comes with lots of challenges, as we have discussed several times. When does it start? When does it end? So we have the beginning and the end, and both are debatable, and that raises lots of questions. And such a timeline, if we begin this way with such an entry point, it means that there would be a linear way to present our findings, but then of course we see it's not linear at all, it branches out. So it becomes at least 3D very quickly. And then, and I think this is close to both our hearts, we like to start with material. So let me stay here. We already mentioned that we traveled the US together, and so we worked at archives archive material would be natural, like from estates. But also if we have estates that are not yet archived, like for example what I did with John Conway's estate in San Jose. Yeah, let's leave it like that. But also interviews are a source of material. What about stuff that people give us that is not in archives, but that we receive, like letters, grant applications, drafts of papers? So let's say personal papers from living people. What about publications? Openly accessible, articles, books, conference proceedings.
And there we could include, sorry to interrupt, newspaper clippings. Just yesterday I found by pure chance something in the New York Times from 1977 pushing how important this project was. It's,
Actually, thank you for doing that, because this is the part where I want to be interrupted. So I will begin, and please tell me everything you think I should add. Yeah.
Could you turn these lights on? That light, I mean, there is a row of lights for the blackboard, isn't there? Sorry.
no problem.
Ah, thank you.
Okay, I'm here. Let's do maths. This is connected to the timeline because depending on what we consider to be a mathematical contribution, this influences the people we look at, and the material we look at, and the timeline. So it's all very much connected. And I'm not going to write theorems down, but we could begin with Holder's invitation, for example, and the context. And then we have things like, oh, but even before that, we have things like the mature groups. We have things like Galois' work, Galois, Abel, all these people. I'm just writing all five to symbolize that it starts with recognizing that a particular group is simple and not abelian, and that this influences something else, in this case, the structure of a group of field automorphisms and solutions for equations. So there's this work, and then there's Holder's invitation, and then there is the background in group theory that we have at the time, like Cauchy and Lagrange and Suloff and Rosat. And then we have all this conceptualizing that happens, and we have some series like Lie-type groups.
So could I just ask, because yeah, is that part of the project to go back to, say, Cayley and his presentations of, or, you know, I mean, there's a huge amount of stuff that happens, and at a certain point, I don't know when, people think, oh, maybe we know all the finite simple groups. So is that part of the project? Is that part of the timeline to look at?
Is it? I'm asking you, is it?
Well, it's your project. I don't.
No, but that's exactly the thing. Stuff happened before Holder wrote his invitation, but how much of this do we want to include? Do we think that this was...
I don't even understand what that is. Is it invitation?
Yeah, invitation. It's what I showed in earlier presentations. It's this Einleitung from his article where he said it would be of the greatest interest if we knew all the finite simple groups. So this would be 1892. But before that, there was already work on finite simple groups. But to us, even in hindsight, it doesn't look like anything that should contribute to a concerted effort towards a classification. At that time, it seems like random results. And even here, there's a long time where still things seem to be random results. And I'm actually asking, what is a reasonable mathematical body of work that captures what goes into the classification.
Well, presumably too, you'd want to have the axioms for a group, and so that's in the 1890s, and these prior things are special cases. That would be my guess.
Yeah, and I think it really is a question. I'm serious the whole time. It's questions. What is the maths that we include? Because that influences how big everything is. This is why we're asking, how big is it? Does it start with the definition of a group?
Yeah.
Does it start with Burnside's conjecture that groups of odd order are soluble? I just write OO for odd order. Does it start with something like that? Something that seriously influences how people look at groups and how they prove theorems? What about Brouwer-Fowler? Statements about how centralizers of involutions influence the group structure, and introducing all these methods from representation theory, or that. I mean, that plays a huge role. And then following all this work where you start with the local property of a group, and then you try to find out something about the group. So you prove characterization theorems. And all this happens in the 50s and 60s. That's a lot going on. And it definitely is very substantial mathematics that contributes to the classification. And again, depending on how narrow or how wide we look at, how narrowly or how widely we look at this, it influences what the material is that we look at and what the people are that we find interesting. So if I say Brouwer-Fowler, and then I have to name things like Yanko 1, the Suzuki groups, Suzuki groups, like a new series of Lie type. And the Rie groups, I think they were before, I'm not entirely sure, but at some point all the Lie types group that we know were known. And then we have the more work of Suzuki, like classification theorems, that became special cases of or that can be seen as special cases of the odd order theorem as we now know it. So that would be the odd order theorem, or in other words, Phi Thompson. And then there is, there's so much. I mean, there's this whole centralizer of an involution business. Then there is this Euler of two structure business that I have not mentioned yet. And then there is the N groups paper. And then there is, I can go on, but maybe it becomes clear where.
There is this bouncing back between results that mark important milestones and then development of techniques that get you to new milestones.
Yeah. Yes, milestones is a good word, thank you. Yes, and there's the back and forth, and then there are these different types of people. Some do something else, but accidentally find a new group. Some search for new groups very strategically. Others prove theorems, and they have nothing to do on first sight with the sporadic simple groups. So there's all this maths. And how do we even begin to define what a contribution is? Is it only the stuff that people did while thinking about the classification and making a conscious effort to contribute to it? Or what about the other stuff that accidentally became important? I find that very interesting. Where do we draw the line?
The difficulty with the maths comes immediately from the unsurveyability of the problem at the start.
Yes, they are very closely
But
linked.
I'd like to ask, I mean, the problem, so when does anybody even think about this as a problem? I mean,
Before Hölder, we have no documentation.
but what does he say exactly then?
It would be of the greatest interest to have a survey of all the finite simple groups of finite order. Yes, simple groups of finite order.
But
He writes that.
But then nobody reacts, right?
Or people do. But at the time, the question is way too difficult. And then for a long time, there's not much that happens. So people would do searches like, let's search for all the groups up to order 1,000, 2,000, 5,000, blah, blah, blah. But the methods don't really change.
Right.
And it takes a long time, and people even comment on that. They talk about stagnation. They talk about how this is still the most interesting question, and maybe the most important, one, but not much progress.
So the question is really out there.
It is really out there, and people repeatedly. So the next good quote I have is from 1947, Hans Sassenhaus, in his inaugural lecture in Hamburg. So he lists a few problems, and he says the finite simple groups are by far the most interesting one, but we don't really make progress. Yeah, so it is out there, and unfortunately we don't have much like documentation, like proper quotes. We have a few, so it seems to be around. It does not, for a while, it does not seem the most pressing problem. It's not like everyone is working on that. Definitely not. And there is a lot of other group theory, of course.
It was a big deal in the US, and George Miller was somebody who produced a huge number of papers on finite groups and so forth. But I think it is exactly what you're talking about. It's basically just of primitive methods of, going through, which was a lot like invariant theory in the beginning too, that basically you had just that type of counting and, working out special cases and so forth, and then finally a theorem comes and sort of,
Is there anything that can be identified as a program until Gormstein comes along?
No, not before. And even he is identified as one of the more important people a bit earlier, but I think we even have a quote where someone says at that time he was not yet the captain of the team, maybe late 60s, but then he became this central sort of strategic figure 72 with this program, even though lots of people didn't believe it could be done, but still there was someone with a plan and with the energy to move it forward. So yeah, of course.
But I think there's the issue of because you had the issue, when does it start? And I think there's the issue of what is it, and for whom this thing is starting. Because if you take Herder 1892, for instance, Herder was quite influential at this time, already in Germany, France, the US, and so on. But, so some people are going to refer to this paper, 1892, others, or sometimes the same people that would refer to Herder 1887. So they do not recognize something that is starting in this paper, or some others may recognize something. But then the problem is that the thing that is starting may be different for several mathematicians at the same time in different places, and the it may also be different. So that's the issue of what do you, in this project, want to know about that? What is your own historical problem that you want to solve? Is it to understand what are the different approaches to, finite groups and so on, or
What is
and for whom? I think for whom is also important. For instance, David mentioned George Miller. And George Miller, so he produced a lot of papers on finite groups, but he was, several prominent mathematicians in the US, they despised him. Explicitly. They say he's not even a mathematician. Group theory is not mathematics. So you have these kind of things that happen in the margins, and it's the same in France. You have like a Jesuit abbot interested in group theory, like Jean de Séguier. You have several people who are like engineers or secondary math teachers. But the big people that do not.
I imagine it's somewhat similar, this sort of thing of despising a specialist in group theory. Yeah. This is sort of, group theory was partly certainly important in the United States because in that new community of researchers, it was something straightforward and simple. You didn't need to know a lot of mathematics to count the next group or whatever it was, and that was the style of someone like Miller. Dixon was, of course, on a much higher plane and whatnot, but it was very, very big. Group theory was very big in the Chicago school, etc.
Yeah, my exposure to these earlier states of the field go through Burnside, and Burnside seemed by writing his groups, books on groups, trying to establish that there was a field there. And I'll just point out one, there are two editions of the book. And in the first edition, he says, there's nothing that representation theory can tell us about the theory of finite groups. And then in the second edition, he says, oh God, I was really wrong about that. So,
Yes, and it's so interesting.
I mean, the idea that there's someone who's trying to make sense of the state of research. I think he does to groups of order 660 in the book, with the methods that he has, but it's not clear that he wants to classify finite simple groups, all of them, but he wants to tell you what group theory can do.
Yes, and he also tries to tell us what he thinks representation theory can do and why it's worth moving this field forward, which then happened as we know now. I would go one step further. I would say that his P to the A, Q to the B theorem is an example for something more structural that happens. So group where the prime decomposition of the order has this particular form are always solvable. That's a big deal, I would say, when you come from checking individual numbers, right?
I would be interested in the immediate prehistory of the odd order conjecture and the Phi-Thompson theorem. When did this path?
The conjecture is from 1911. I think the first.
Who was it?
Burnside in his book in the second edition, as far as I know.
Oh, it's already there.
Burnside was really visionary in some ways. And then there are some special cases. The first explicit special case that I know of is in one of Suzuki's papers, sometimes in the late 1950s, I believe. So Suzuki did all this work where he would start with a local property. For example, he would say, I study groups where the centralizer of all non-trivial elements is a billion. Or maybe not for all elements, but maybe just for elements of order 2. Or maybe the centralizer is not a billion, but it's only nilpotent. Things like that. So he would start with something very local. So basically you step into the group, you find an element, you know something about all the elements that commute with it, it's local information, but then you start to extend it and you find out things about the whole group. And he did one of the first special cases that were later relevant for Veit and Thompson's odd order theorem. So Thompson himself also did a strategic.
So when is Suzuki?
So the papers that I refer to are in the late 1950s and early 1960s, and the proof of this was, I think the publication is 1963, 62.
Yeah, something like that.
I look at Adler, yes. So a lot of this work was done at the during the Chicago special years, 60-61, that Volker mentioned, which is why material again becomes relevant, because the more we know about this year and the finances and who else was there, the better we can maybe understand the influences that went there and the historical context.
So I think you said that the Suzuki groups are special cases of Lie-type groups?
There is a series of groups that's called Suzuki groups, and that's one example of a series of a finite simple group of Lie-type that's exceptional. There are classical and exceptional ones. So for classical ones, you can think PSL, something, PSP, PSU.
So I wanted to ask about that. So, you know, this, that was one of the points I was trying to make too in this talk I gave for you, that classical mathematics and what pushes through and becomes modern mathematics, and what's the transformation that takes place. So Lie groups don't exist in the time of Sophus Lie. I mean, the modern notion of a Lie group is come on by in 1925 or something. So the Lie-type groups are, of course, a finite version based on...
To your mind, what is a group of Lie-type? Let's just clarify, we talk about the same thing.
I think...
Because Lie groups and group of Lie-type is not the same thing.
Right. So, but it presumes that you know what a Lie group is, right? A Lie,
Not really,
not really.
to understand the
Well,
definition.
anyway, you need to have finite fields and things like that. It has to be a finite group, and Lie groups are not finite, so there's some
Exactly.
analogy being made with something.
There's so many ways to look at it. Historically, I don't know whether when people started to talk about groups of Lie type, as we do now, whether Lie groups, like infinite and with continuous stuff and so on, how much that played a role. I don't even know. That's part of a project that I want to do.
Okay.
For me, it would be completely counterintuitive now to talk about finite groups of Lie type and to talk about Lie groups first. Because for me, there's no connection really. Maybe there is historically, but now if I wanted to
When do
introduce
people start talking about Lie type groups?
Chevrolet, no?
Yeah, exactly. You have the
Chevrolet in
diagrams,
40s,
you have the types, and then you have the finite versions that come from being fixed points of certain automorphisms.
Right.
But this is the issue of the connections, as you said, which I think is crucial because that's the what is it. Even the term group, I mean, has different meanings in various types in social spaces. For instance, in the late 19th century, the Galois group, it's actually three groups. The groups of modular equations that are especially investigated by Hermite and Klein and so on. It doesn't, I mean, at all has the same meaning as we would nowadays expect from, the Galois group. And I think this, this is the issue behind what you said about the Lie groups and the groups of Lie type. These meanings, they may change.
Exactly.
And so you have to identify the collective dimensions in which finite groups or I don't know what is going to take this or that meaning and change.
Yes, and I do not think that it is within the scope of what we do to go back to the definition of a group.
But it's not always a definition, it can be a social practice. For instance, the Galois group, as understood by people like Hermite and Klein, they never defined what they considered as the three Galois group. I mean, they know what.
I know, and I understand, but at least for me, please disagree with me, but at least for me, if we talk about it, for me this is a very specific question about a very specific type of groups, and the definition of a group and a finite group and normal subgroups and what simple means has to be established at that point. I will not go beyond that and start discussing that.
Thanks. I wondered about that because I think
no, thank you. But that's part of the thing, right?
Yeah. Because I think that's a difficult issue. For instance, for a long time, even Burnside, in his books, not his papers, they never distinguish finite groups from automorphic functions because that's the larger context in which things make sense when you're a good mathematician, not like George Miller, who's like a specialist of finite groups. And for instance, I looked at the diedro group, and to my knowledge, it's only in the 1930s that you have mathematicians discussing the diedro groups without discussing at the same time automorphic functions.
And to this day, there are very different views on what a dihedral group is. Some people come from geometry; they will even have different notation for it.
But I think that for your project, there is this key issue of when then finite groups they are discussed just for themselves, not embedded in analysis or geometry or whatever. I think that this may be. To my opinion, more important than, for instance, just like a program like the one of Waldecker. The time when it's considered as a field in itself, as an object in itself that you can study, and it's legitimate. And
how would you begin to find evidence for
I don't know, but I would suspect it would start in the 1930s, something like that, quite late.
Really?
Because I think that before you have people in the margins, like classifying finite simple groups, like we said before. People doing things connected to other things. Mathieu is a good example, but of course Burnside as well, because there is this larger issue of automorphic functions and so on. Frobenius also, many people like that. And I'm not sure that before, it's quite late, but I'm not sure that before that time, it's legitimate, to say, okay, I'm working on finite simple groups. That's my research. I'm not sure. But I don't know, it's an open question, of course.
Maybe just a question about people, since you have a couple there, and Volker, in the beginning you mentioned that there was a connection between Chicago and Frankfurt. So did this have something to do
Freiburg,
with
right?
Reinhold?
Frankfurt.
Frankfurt.
Reinhold Beer, did he have something to do with that? That,
Later on, yes.
but not
I mean,
not in 1961 or whatever.
Well, yes, I think he returned to Frankfurt in 57 or 56. And he built this group of young people there who were all in group theory or in finite group theory. And Fischer being one of those coming out of that.
I can put a few more names down, but
I mean,
here it becomes interesting because now we can discuss whether we would like to distinguish between a mathematical contribution, a strategic contribution, a contribution by building a school of people who then prove theorems for the classification.
So, so I wanted to ask about it too in the context of what you brought up, the Cold War mathematics, and you know, it's fundamentally a U.S.-American enterprise, this project. But to what extent were, say, people in Frankfurt or in West Germany, how international was it as such?
That is, of course, a good question. I mean, and it's difficult to assess again, because if you just look at the publications, it, of course, looks very international. If you look at the group of, or say, a possible group of core players, then you will find it is very much centered in the US and the UK and in Germany. That's the three big chunks, I think.
You showed us this map, didn't you, last week?
Yes, I showed you this diagram. Yeah. But then, of course, it's difficult to say what is a core player. You can do a citation analysis and end up with a paper being quoted hundreds of times, but not being really relevant for the specific community. It all happens. We know that.
And then you have people who are mentioned by almost everyone in the interviews as being a crucial player, but with any quantitative analysis, they would never appear. So how do we deal with that? We can fill the boards in any order that you like. Please just keep throwing it at us.
I'm sorry, could you name someone who played that role?
A person who would fall, who would not appear with quantitative measures, but who by many people is named as a
Yes.
Helmut Bender.
Uh-huh.
That's actually, I'm a granddaughter. Helmut Bender is my mathematical father, a mathematical son of Reinhold Baer. So that there were some people who did a particular kind of group theory that, as some people say, played a major role towards the classification of finite simple groups in terms of, not in terms of finding a sporadic group or something, but in terms of proving some really impactful theorems and developing methods along the way that others picked up and then developed further. So in a way, it was crucial for the whole texture. But if you only find 1 or 2 or 3 publications that are then picked up and cited, then the impact of these people will not become visible with any quantitative method. There are a few examples like that, and then there are, of course, others where you have a one-on-one correspondence between what you find with quantitative methods and what you would find if you read self-historicization articles and talk to people, which is one of the things that I find very interesting. So where is it just a good story, and where are we overlooking something if we just follow the good story? I would like to come to this because we have not talked about this much, and I just want to open this. So often when we get asked about this project and we begin to tell a little bit why we find it so interesting, then people ask us, when can we read your book? So I guess we maybe should write a book at some point, or maybe several, I don't know. But who knows, maybe a book giving an overview or something, I don't know. Of course we write articles. We have very different audiences as well, so I can think of at least 5 just from the top of my head. Then we give talks. 2.5 years ago, I was here for a conference, and one of my colleagues gave me a crazy idea that I have not completely lost, but I don't think it's feasible. He suggested that we apply for money for a video team, like a film crew, and I should travel and I should go to all these people who contributed who are still alive. I should do interviews with them and it should be filmed and we should make a documentary, a film, like a video documentary. I put this here, although I don't think it's going to happen, because this is something we have not yet mentioned. However we identify these people, whatever definition, they die. Alternatively, we could think about something audio, because we have lots and lots of interviews and there are more coming, and if we ask permission and if we're allowed to take snippets, maybe there's a way to do audio material. And also, now this is probably crazy, but coming from there, I'm thinking of a YouTube channel, History of the Classification of Finite Simple Groups, 10 minutes, Volker or I hold up a piece like a letter or a grant application or something, and we tell in 10 minutes why this is an interesting piece to understand a part of the history of the classification of finite simple groups, and on and on and on we go.
Why not a more organized website?
Oh, this is also on my list. So let's say short videos. Yes, a website. And what I envision, also we want to create an archive, like a digital archive, but also a real life archive. What should I say this is called?
Well, an actual archive. Depositing the papers somewhere, in Göttingen, for example.
So let me put archives. Website, yes. What I envision is an almost interactive website that's like a big wall painting or tapestry or something, and you can zoom in and then you go to a particular thing that you find interesting, and we have seen how many levels there are where you could zoom in. It's like different colors, and then you pick a color, for example the people color, and then you choose a person and then you zoom in and then you find information like links to something, or maybe an article, and then from there you can move to other places, or you can step back, look at the whole wall painting again, choose a different color, and choose a different topic, and then enter again. So I would love something that is sort of vast and explorative and maybe interactive. Not quite, it would be like zooming in and zooming out, but you would have possibilities to find a point and from there go to other places. If anyone has any idea how this could be put to life, so if you know of any software, please tell me, because, I mean, this is what I dream of at night.
I mean, this, on the left, the top book talks, articles is what we, of course, have to do, because we want to get funding, etc., but we are not so sure that that will be the best way to really share the knowledge, show what we found in terms of material, in terms of interviews, etc. So I'm very much, well, I like the idea very much to, well, do a tapestry, to try to do something different, because, well, a book, it will be nice, 5 people will read it, 500 will look at it, but yeah.
Any other ideas when it comes to dissemination, and in particular, how can we take into account that we have this time-critical component? So there is stuff that we can only collect, there's material, there's information that we can only obtain while the people are still alive. How can we take this into account? Oh, and also, we see how this is big, right?
Yes,
I hope.
How big is it?
Yeah. Any ideas?
I feel I have to go back to the timeline question because I'm not convinced we're even at the end.
What would be the end for you? What do you think?
You have hinted that there may yet be a third generation proof.
Oh yeah, but that's not so much in timing, like taking this and then condensing it again. No. This is in terms of different methods. So I know of one project where fusion systems will be used. I know of another approach where you take, and they might be combined in the end, I'm not sure. There is an approach where you look at finite simple groups of Lie type, but somehow without starting there. But you look at local properties, and then what you study is, so at the back of your head you think, I am basically studying finite groups of Lie type, but you study them from a more general perspective, and therefore you can not only develop a more general theory, but also you might end up with theorems that actually classify and characterize these groups, and that might also lead to parts of the classification being transformed. But what I do not know of, at least, I should be careful, I do not know of a second, fourth, fifth generation proof in terms of we take what we have and just do it again and organize it differently and write it up more in a more condensed form. No. What I see is that people look at different methods and how we can look at the classification from a different angle.
So looking at it, as you're talking about this type of thing, you get very deeply into stuff that very few people know about, but of course many mathematicians had a general awareness of the significance of the project and so forth. We just, in our little reading group, talking about the Jaffe and Quinn debates and so forth, and not only in their paper, but also in some of the responses, it was brought up, this project and so forth, as an example of an ongoing thing with maybe problematic features or whatever, but something people were aware of and talked about. So that maybe leads me to ask or to wonder, wouldn't it be worth it, instead of going in too deeply and in such a detailed way and talking about just the people who are in the inside, to maybe try to interview somebody like Gromov or whatever, who from a totally different perspective is very had a huge impact on other groups and so forth, but might have an interesting view of the project as an outsider, or look at things from taking the perspectives of people who are outsiders but knowledgeable and maybe have something interesting to say about it, instead of just trying to document how it was done in such great detail and everything, because in the end that's of course hugely interesting for the people who were involved, but I'm not sure that it interests the mathematical community that much, or historians of mathematics or whatever.
Well, I think that goes for many projects in the history of mathematics, and that's the question of the audience, of course. But I think we would have an interest in doing such interviews.
I'm already doing it, actually.
You're doing it, but if you wanted to do that in a systematic way, it would be quite problematic to decide
I'm
on.
not suggesting anything like that, but it might just just getting other viewpoints and not focus so much on exactly the people who were involved. Although, as you say, a lot of the key people passed away, but
or will soon pass away. And this is why I would like to question the word that you used several times, instead.
instead we.
Yeah, so you phrase it like this. You said, instead of focusing on core players or maybe core marks, we could go to the sidelines.
In addition to.
And while I said, I'm already doing this, I wanted to question this instead, because you would have to give me a very good reason why the people on the sidelines are more important than the core players when it comes to people getting old and passing away.
Well, no, I absolutely think you should interview anyone you can, especially significant people. I didn't mean to imply anything other than that it might be nice to supplement that with, that's all I meant.
Yes, so what, Where do you think, I mean, let me phrase it differently. Can you see, in your, from your perspective, what is the difference between material that can only be understood if we actually go into the depth of the maths and material where we don't need this knowledge? Because this also has something to do with how we share the knowledge.
You might want to repeat the question. I'm not really sure I understood.
You said that you think that maybe some of these details are not interesting to certain audiences, and
Well,
this
if you
might
go
be
into
true.
deeply, I'm quite convinced they won't be interesting to other than experts, yeah.
Yes, and this is probably true. On the other hand, knowing these details and following some paths through these details is necessary in order to find some of this material and to find parts of the story that would then again be accessible
Well, in
to
the end, it's
wider
when you do
audiences. So I'm
history,
just
you're selecting out all the time. So of course you need a whole lot more knowledge than you're ever going to put out in the end. Absolutely agree, yeah.
So it would be a matter not so much of us not looking there, but if I understand you correctly, it would be about, depending on the audience, not telling all
Well,
these
maybe you should tell
details.
us what your thoughts are about the audience, because that's not so clear to me.
All right, do you want to start?
Yeah, I mean, one reason for me to stick to the period 50s to 1980 is that that is when the classification as being perceived of as the classification effort by people like, say, Brauer, etc., really accelerated, and they were on track. So that is a period I would really concentrate on, and that, of course, is connected to the political circumstances, this big mass what we've been toying around with. It's geographically widespread, it's resource intensive, you have to do teamwork, you have to do a leader or captain of the team. And so these are all things that are really also of great interest, I think, beyond the two standard audiences we would have, and that's of course mathematicians, or maybe only a subgroup, but that's a problem we all live with when we do history, that we very often only have subgroups of mathematical communities who would be interested in that. The other community being historians of mathematics as such, because I think you can tell a lot of, or learn a lot of things by looking at this example. And then for me, another audience would be, well, at least historians of science, because I have the feeling that history of mathematics or mathematics as such has often, too often been, well, not held in sufficient esteem in history of science, let me put it that way. So that would be three of my core audiences, and that is, I mean, that is problematic because you really have to write in different ways for these audiences, I think.
Yes,
and
I'm glad.
You are at least five. I am curious.
Well, I have a few more, and therefore I'm grateful for comments like this, because it's so easy to not get it right what technical depth might be suitable. So some people might actually be interested in more technical details than you think, and others in less. In particular here, where there already is a lot of, well, not a lot, but some literature like books and articles that are meant for a more general audience. It's interesting to see where they find their level of technical difficulty. So yes, I'm actually grateful, because it's one audience that I have in mind additionally that I want to mention is people who are just interested in maths. They don't need to be mathematicians, they don't need to be maths historians or anything, but they're just interested in mathematics, because here we have lots of interesting stories to tell that can be told, partly, without knowing technical details about finite simple groups. So it can even be an entry point for people who are just interested in what is maths, what is mathematical research even like, do people just multiply big numbers all the time, or is there something else going on?
Have you thought about the general issue in this time frame, whatever you choose, to focus on, in this time frame, comparable attempts or theories or whatever to classify certain types of objects and so forth?
Nothing of the scope. There is nothing of the scope.
Well, that wasn't my question.
Oh, sorry, okay. I thought if there's nothing there, then we don't attempt to
No,
find
I
it.
wasn't implying it had to be of some scope. There's the general problem in mathematics of classifying things.
Oh, yeah.
So when,
Yeah, that's, I mean, of course, but we are, in this project, we are really interested in the scope, as I am interested in it because it has a very specific scope. Of course, it's in a tradition, it's in a tradition of doing classification of things.
Yeah,
that
let's-
goes back to, I don't know
Yeah,
when.
let's see where the question goes. I think I'm not yet understanding where you want to go.
yeah, so because Rebecca was referring to people interested in mathematics and classification of objects is obviously at some point wasn't always there. I mean, when does that become an important thing, and what would be a accessible and obvious example of something that you would maybe want to consider as background, just as, you know, mathematics is pure mathematics is a field in which classifying objects.
But what is striking is that in the 19th century, the classification, at least I know about, I mean, it's about geometrical objects. And it's very often connected to a kind of naturalistic philosophy of mathematics.
Not rigorous.
You know, cubic surfaces, and then afterward you have these models, you're going to show the public, I mean, the different types of cubic surfaces. Whereas here, it's almost the opposite. It's classification. But so, I mean, do you still have like this kind of naturalistic ideals that like finite groups, I mean, they do exist in nature? And we're going to find them, like, you know, butterflies with our net, or I don't know.
Well, for all these groups, of course, we have to show existence.
Yeah, but I mean, mathematical existence is not, you know, it can be a kind of.
Oh, I have not met any of the finite simple sporadic groups on the street yet. That's.
But I mean, mathematicians.
What do you mean?
I wonder if the mathematicians you interviewed and so on working on that, I mean, if that. Maybe they share a kind of internal philosophy of mathematics that may be more naturalistic than...
Can you explain to me what you mean by naturalistic when we talk about...
I'm just comparing to the 19th century, like people like classifying cubic surfaces, for instance, they really consider that, I mean, it does exist in nature. And so they have...
Does a perfect cubic surface exist in...
yeah, it's really like the old, I think, Platon idea of mathematics, like it's natural sciences, and it's the first of natural sciences, and so it's the world of ideas. I mean, it exists somewhere. So of course, it's not perfect cubic surfaces in nature, but it reflects something that.
If we talk about it in that sense, then yes, of course. I mean, if you can construct a graph and the automorphism group can be shown to be the group that you look for, then you have constructed the group in real life as much as is possible for a mathematical object to
I think that would be interesting, I think maybe also for the history of science, if there is something specific regarding these mathematicians, because nowadays you have many mathematicians, I mean, really assuming math is all about fictions. I mean, it's, you know, like the fictional philosophy of mathematics, I mean, that's become a big thing. So if there is a kind of specific internal philosophy of mathematics maybe more naturalistic in this area, that may be, I don't know.
Something as primitive as generators and relations.
Yeah, but even there, I mean,
maybe
maybe this is naive, but if I think of the conversations I have, then I would say that there are in general at least two flavors of mathematicians: the ones who think they invent stuff and the ones who think they find stuff, and sometimes they have to prove that they have actually found what they claim they found, and maybe flavors in between. But I cannot see how this would particularly play out in the classification project, because if you want to. So if you have evidence for a new group and then you want to prove its existence, so you need generators and relations or you need an explicit construction, then I cannot really see, and therefore I'm struggling with this word natural or naturalistic, I cannot really see how you would spot in the work whether this person thought they invented the group or whether they found it.
I guess it depends of the mathematicians. I mean, I don't know. But
Yeah,
you could
I'm
be-
trying to understand why this question is particularly relevant here in this context.
Maybe it's not,
Can
I
I
don't know.
do another take? I think that this is probably even more naive, because until you talked today, I didn't understand that the question of classifying finite simple groups actually took a long time to make sense and be asked.
Yeah.
But now I'm wondering, after being convinced of that, when you look at, is the finite part, is that a natural boundary? And because, at least in my field, a lot, topology and stuff, a lot of the groups that arise are not finite, they're finitely generated or so on, and you have interesting theorems. David was talking about Gromov, it's certainly
Mhm.
the stuff that came out of Thurston's thing. Where do they, perhaps there's the natural, the finite is not so natural. I'm not, I
Oh, this
know
is
that's
interesting.
very vague, but.
Yeah, this is interesting because I can immediately see how you could have so many different perspectives on what natural means. For me, having a group of permutations of a finite set is completely natural, and therefore all finite group theory for me is completely natural, plus you can do induction. And that's one of the big differences between the first generation and the second generation of the proof. For the second generation, when you had a list and basically a theorem that you know you want to prove, you can have an inductive approach and strategy, and that changes the game. Whereas for infinite groups, I wouldn't know by what measure you could try and do such an approach.
That's true, but if you've got a finitely generated group, I mean, you perhaps
Use
one
the
can-
rank or
You
something.
can do, yeah.
Yeah, okay. I have no idea because I find infinite things slightly scary. I don't work with infinite groups. I have no intuition for their methods, their theorems, and what kind of bigger projects there might be around. I have absolutely no idea. I really don't know.
Well, I know far less.
But of course, so coming back to what David said earlier, of course it's interesting for us to look at this project not just by itself, but also every now and again in the context of research in algebra or even just in group theory more generally, because we do not want to go into this trap of thinking that the whole world revolved only around this classification project. Of course, there was other group theory happening, other finite group theory, but also infinite group theory. And yes, of course, it's interesting for us to talk to people who were kind of close enough to see what was going on, but far away enough to not be in the middle of things. And their view is, of course, very interesting for us. Sure.
What about, what would you, maybe, you know, I don't know much about these takeoffs, but one of the most famous, I think, is Conway's Monstrous Moonshine, where this huge sporadic group and representation of it and so forth, which I guess to this day is still intrigues a lot of people and so forth. Is that a singularity, or is that one, or were there other things like this, aspects of the project that excited famous people like Conway or others to pursue some avenue connected with it?
I would say there are a few more. Do you want to give us one or two examples, Atla? Spontaneously?
I only know that there's like Moonshine for the online group, which is not contained in the monster, so it was interesting to see if there's like some other modular function that has the same properties that the monster group and DJ function have. But other than Monstrous Moonshine, I don't really know.
This is certainly one of the most famous ones, also because it has been taken up by people and they wrote like popular literature or literature that was easily accessible. There are certainly other individual groups that got a lot of attention, like from different angles, different ways of constructing them and so on. And then there's also this whole area where you can see how finite, let me say finite simple group theory maybe, is intertwined with other areas, for example, geometries or graphs or representation theory. And then there will be...
What about Steiner triple systems? Is that,
For example,
something that-
so just now there was a whole book just about the mature groups, and mature group M24. So somehow these so-called Steiner systems, I think they should be called differently, they still raise a lot of attention. Everything combinatorial that is going on still gets a lot of attention. Also because, coming back to this point, it makes the groups more tangible.
Well, those things are classical, actually, mature groups and Steiner systems and all of that. So that, I would say, kind of falls out of your period in a way. There's
Yeah, it predates this.
a ton of examples like that, which are, because after all, you know, symmetries and all these sorts of things in geometry, a lot of times new groups popped up and, you know.
I'd like to come back to the communication problem, and in particular to identifying the audience, because the degree to which your audience is expert or not requires a different kind of communication, and the less expert your audience, the more you have to rely on metaphor and simile and suggestions of what complex techniques were used in order to achieve the various elements of the classification, and that I think is that's a serious project in itself.
Yes, I totally agree, and I think that the big mathematics framework is really well suited to exactly that, because you can understand a lot about these 5 points that we make without knowing any deep technical details about the classification. And another thing is, I'm coming back to people, the community thing is also something that we can elaborate on a lot without going into deep mathematical details. So I think this even is a story that can maybe address some of the prejudices that many people still have when it comes to thinking, who is a mathematician, what does a mathematician do, how do they work?
But I would counsel you against pushing it into the sociology and away from the history of the ideas.
Yes, thank you. I'm very aware of that, and I want to defend, in a way, that there has to be a corner, or there needs to be something in the tapestry for people who actually understand the group theory and who actually are interested in, like, they want to go down the rabbit hole and really understand the history of the odd order theorem, for example, with all the technical details. And I'm aware that this will be few people, but it's crucial to address them, and I want to give one reason that we have not yet discussed at all here. There was a time, decades probably, where people were actively discouraged to study a particular type of finite group theory. And this has to end, because if we keep discouraging people from studying finite group theory, learning about the techniques that were used in the classification, then in, let's say, 50 years' time, we will have a theorem, and no matter how surveyable the proof, who will understand it? Who will be able to use the classification with any sense? And who will be able to push the methods further, maybe prove new stuff, and make more applications of the theorem possible in the future?
There's the opening paragraph of your preface to your book.
Yeah.
Oh, maybe. Did anyone write this down? Yeah, so we have not addressed this, but this is a huge deal. And we can see it. I have statements from people in interviews. We can see it right after the announcement. But I, many years later, as a young postdoc, was actively discouraged from doing the research I do. And this has to stop.
There is one aspect that we have not mentioned, which, no, not for the blackboards, but for framing what we are doing here, because we are in the first phase of our project, so we are still defining in a way the contours and what we really want to concentrate on in the second phase that might be coming next year or so. So we are very much interested, or were interested in getting your input here, because for us this is not something, we don't have a clearly delineated concept of this we will do and that we won't do for funding agencies, yes. and how we will do it. That's something that we really we have to discuss over the next few weeks or so.
Mm-hmm.
And that was one of the reasons why we wanted to get you on board in discussing this. So this is not a project that has clear contours and we know we will go there or there. I mean, we have a feeling of where we want to go. Rebecca has feelings, I have feelings, we have joint feelings. That's fine. Yeah, that is a background to this, because sometimes some of the questions were very much tuned towards a project that's already clearly defined, and we are still in the process of defining and seeing where we want to go and where we can go, because funding agencies, that is of course an important aspect. The two of us cannot do as much as, well, 4 people could do. So we have, luckily Atle is doing his PhD with Rebecca on the sporadic groups, so there's a chunk that you can take and, well, have a person working on, but other chunks are there that will probably not get an individual person working on it for 3 or 4 years.
Yes, and we also have to keep in mind that there are things that other people can do, and then there are things that basically only we can do. Sometimes something requires this very special expertise. And maybe we can use a few minutes here with you while you're here. Could you advise us on what would be a convincing, let's say, portion of this, or where could we put our focus when we now want to convince a funding agency to fund this project for, let's say, 3 years, substantial amount of money for us to travel, to look for more documents, to do more interviews, maybe also for another PhD student. So if we think about the different audiences, and if we think about all the layers that we have discussed, in your opinion, what would be a convincing case? Where do you see the strongest points that we could make to get funding for, let's say, the next 3 years? What is your feeling about that? I will take any ideas, please.
Depends sort of on what funding agencies.
German Research Foundation, for example. So it will be, so maybe they've seen this project before, maybe they've even funded the project before, and now we need to convince them, or a very similar agency, we would like to go on, we need more money.
But you have a startup funding from them, right?
Yeah.
So that's a natural thing to follow up, and I guess you're asking what accent to put on it in order to get a bigger thing, you know?
Yes, exactly. Thank you.
Okay.
So of course we have ideas, but we would...
Yeah, but your impression is important,
Yes.
because you are the ones who have now seen us talk about this, you have asked us all these questions, and people like you might review this. So what do you think would be convincing? What would make people curious?
Do you know a billionaire who would just love this?
That's the
Well,
more relevant
go to the
question.
Steiners Foundation. I consider that.
Donors, yes. Well, there's other pockets.
The approach that picks up the question of big mathematics and Cold War mathematics is something many people are interested in.
Okay.
So I think your intuition is correct to attach yourself to this. And the period you're investigating is the right one for it as well.
Okay.
Yeah, I would agree with that too, that I honestly think that that's great that, you know, you have tremendous knowledge and detailed knowledge of the prehistory and all of that, but it's a huge thing anyway, and it makes sense. You put the Cold War label on it and whatnot, that gives you a timeline right there. You know, and I think that, you know, obviously there can always be some, you know, in the write-up there can always be some prehistory, but the proposal should surely be for that time period you've got up there already.
Okay, focus on the timeline. Yeah. Thank you.
But these are rather I don't think we're saying anything you don't already know.
Right.
Yeah, but still, I mean,
Good to know.
we could be wrong. We could have blind spots. I mean, we certainly have.
I'm wondering if you were in a pub or something over some beers, and you'd said a book is a long time away, but a lot of what you've said here and pieces of mathematics would be of enormous, I think, popular interest to mathematicians. And so if you were thinking about trying to write a book that was accessible to someone with an undergraduate major in mathematics or something like that, or define an audience, but kind of somebody that would know about group theory. What would a current history, and history isn't the right word, a current description of group theory look like? And so it would want to include, I think, more than just finite groups, but it would certainly want to do that. You might want to look at, and maybe, Rebecca, I just heard the tail end of Hooker's talk, saying that you were interviewing people. If you interview, there's some people, Gromoff, for example, would be a very good person to interview, while and other people while they're alive still, and interested in what they're doing, because it hooks up. So, but if you could identify, in a way, a large thing of subject material that you thought was explicable to someone with a undergraduate degree, say, I just think graduate, or maybe you want to give up on that and just do it to practicing mathematicians and history of mathematics people. But you don't have to write the book, but if that set of knowledge was there, it could be part of a grant proposal that will ultimately be a project.
I kind of thought you were going to go in a different direction, which I'll now attempt.
Okay.
A different direction being, because he wrote a very nice popular account of the Poincaré conjecture and how it was solved and all that. Very popular, very technically difficult topic. Yeah, he began by saying, by what you presented here already, you could probably write very quickly, this is my take on it, you could probably write something very quickly that was accessible at a kind of simple level as a basis for, now I want to do the real thing, and that might make the proposal, might make it stronger, just having that type of a work that has a more general audience, and that could just, who knows, how people see these things, but...
A few weeks ago, Karen gave this talk for the history of American mathematics, where she told the story of how she and you wrote this chapter for the centennial editions that eventually expanded into emergence there of that community. I think that may be a good way to pitch this. And, there is
something like that.
Maybe there is a book that you start with to sort of
depending on whether you thought you could write it quickly enough, I guess.
Right, or maybe don't write it, but you have an outline or something, and so.
You started with the pub.
Yeah, that's what the pub is
This happens to me all the time at parties, family gatherings, in the pub, wherever. So people ask me, and then I have to do exactly that. I have to explain in a few sentences, really low level, what I do in this project and why I find it fascinating. And then depending on how scared people are of maths and depending on how much my eyes sparkle, they might move on and ask more questions, and then I can go into details maybe.
Yeah, and sometimes when you go into the details, you realize you can't explain it, or you can explain it, but it's just too much of a rabbit hole, and you can't go there.
Yes, but then we're back here. Because if I'm in a conversation, then I can ask people, do you want me to go into details here? And if they look scared, then I just don't, and I go somewhere else. But sometimes they say yes, and then I try, and then it's a challenge.
The website seems to me, it seems like a wonderful project, but it seems, that's much scarier to me than a book, if I were doing it.
Except if you've got students involved, then it's not scary, because they love that
If you
kind of
get them
stuff.
in it, that could be.
That's why I was asking whether anyone knows of any software that I could toy with just to explore and just to see what is possible. Because, yeah, I also see myself starting that with a bunch of students.
It's called ArcGIS. I know the software.
Excellent, thank you.
I've made the case to Rebecca. Danny's point is very important, but I actually think this could go much broader. And the article I have in my mind is there was an article in the New York Times about 2 years ago that was really about machine learning, but it wasn't about machine learning. It was about how doctors who were trained like 40 years ago, who are still working, and now these early career doctors who know things like machine learning, and how they can communicate better to share the expertise from the lived experience of seeing bodies for 40 years, and the new doctors with this machine learning can come together. Now, your connection isn't machine learning. I really think it's this teamwork, both of your team and of what was going on back there, because that's not something people associate with mathematics. It's very difficult to get a wedge in the New York Times, but I think this could, I do agree that you like your corner for the group theorists and Danny's point about deciding your audience, but I do think you have a very broad audience. It's called public scholarship. I've already made this pitch to Rebecca. I find this a beautiful way
I think you're right.
to connect mathematics.
Yeah, I think this is so, I'm grateful because this is why originally a part of my brain wanted to go big, just because of that, yes. So I feel encouraged by that. And at the same time, we have to convince funding agencies and we have to speak to all these audiences that have more specific expectations.
But the NSF requires a dissemination piece.
Yeah.
I can't believe on that rating, I can't believe anyone would beat you on that. It's such even students doing a website, that's another dissemination that's unusual.
Yes, thank you. I take this as great encouragement, just as I take all the critical questions or comments as great encouragement, because this is exactly what we need. We need it before we write the grant application. We need to see the critical points where we might get it wrong or where we might have overlooked something. Thank you very much.
And in the same way that I mentioned the difficulty of addressing a less prepared audience, I also think that the effort you invest to try to address a less experienced audience is well worth it.
Yeah. Where is the rabbit hole?
Yeah.
Right?
Where's the rabbit hole?
I mean,
that's a question.
But yeah, okay, yes, it's a question. I wanted to, okay, it needs to go on both. I don't know how to write this.
Yeah,
Is this correct?
That's right.
It's really where's my rabbit hole, right? For each audience, where's my rabbit hole? And then where's the next one, and the next one, and the next one? And hopefully people get drawn in, and then they end up in a place they didn't even expect. This is how I envision it anyway.
One should understand that group theory, whatever that means now, is different after the proof.
It is.
And so, what will ongoing research in group theory, how will it depend on the proof?
Yeah,
and then if the proof becomes forgotten, then will we have to do it over again? I mean, So,
It would be interesting, right, to imagine people forget it, and then in 200 years they recognize, oops, oh, but we need such a theorem, let's do it all again, and who knows what they come up with. And also I wanted to mention that there are other areas in mathematics that are heavily influenced. For example, lots of big conjectures in representation theory begin to fall now because people have an inductive strategy and they use the classification. It's marvelous to see this.
Well,
it's late. Thank you. Thank you for taking so much time. We should go and have some lunch, right?
definitely.
Any
Thank
closing
you.
words, Volker?
No, thanks a lot, and we will profit from this, of course. And some people like Della will hear from us about she's running away.
We'll catch her.
Catch her. Yeah, thanks.